Have you ever been there? You're mid-project, maybe setting up a conference room or even a home theater, and you're just staring at this massive tangle of HDMI cables.
Oh, yeah. Trying to get that signal across the room or
Right.
even further.
Exactly. And you hit that wall, signal drops, the picture gets fuzzy, or maybe it just doesn't show up at all. It's incredibly frustrating.
It really is. A common headache for sure.
Welcome to another deep dive. Today we're tackling exactly that problem. We want to understand how the pros get crystal clear audio and video over, well, surprisingly long distances.
Mm-hmm.
We're focusing on a specific piece of gear, the WolfPack 4K 30Hz HDMI transmitter over HDBaseT.
Right. This isn't just your average extender box.
No, it's a window into how serious AV systems handle our, ever-increasing hunger for high-res content, sometimes across whole buildings.
It's a great example.
So our mission today is to really dig into HD-based technology. What is it? How does this WolfPack transmitter use it?
And crucially.
And most importantly, what does it mean for you? If you're trying to get reliable, uncompressed, top-quality AV over distance without tearing your hair out over signal loss.
Yeah, and it's funny, we often just expect perfect video everywhere, right? Press play, it works.
We totally take it for granted.
But behind that seamless display in the auditorium or the conference room video call or even that amazing home cinema setup,
There's a lot going on.
exactly, there's some clever tech making sure that signal stays perfect, even over hundreds of feet. This dive should really shed light on the how and why for you.
Okay, let's lay out the core problem first. Standard HDMI cables, they run out of steam pretty quickly, don't they?
They absolutely do, especially beyond, say, 15, 20 feet reliably. You start pushing it further.
Them things get messy.
Yeah.
Signal drops, quality tanks, maybe get sparkles, or just nothing.
Right. It's a physical limitation of the spec, a real bottleneck if your source and display aren't close neighbors.
So the big question is, how do we beat that distance limit but keep the quality pristine?
And that's where HDBaseT comes in. It's the tech powering this WolfPack transmitter.
Okay.
And its core promise, well, it's pretty ambitious. It talks about no compression, no losses, and no latency.
Wow. No compression, no loss, no latency. That sounds like the dream ticket for AV.
It kind of is, yeah, especially compared to other long-distance methods that often have to compromise on one of those.
So how does it pull that off? The info we have says it uses a single KT6 or KT7 cable, like standard network cable.
Exactly. Just one regular Ethernet cable,
Yeah.
KT6 or maybe KT7 for best results. And that, that's a huge advantage.
How so?
Well, think about it. That kind of cable is everywhere. It's often already run in buildings for networks.
Right, infrastructure might already be in place.
Precisely. So it simplifies the wiring massively. Less bulk, less specialized cable, and honestly, often lower costs than running proprietary video cables long distances.
Okay, that makes sense. This WolfPack specifically mentions KT6, but KT6 or 7 are options too.
Yeah, for optimal performance, especially if you're pushing the limits on distance or resolution, Cat6A or SAT7 is often recommended. Better shielding, more bandwidth headroom.
Gotcha. So let's zoom in on this WolfPack transmitter itself. What are its headline features, particularly around 4K?
Okay, so the big thing is definitely its 4K support. It handles both 4K at 60 Hz and 4K at 30 Hz.
Right.
But here's a key detail for you, the listener. 4K isn't monolithic. This unit does 4K 60, but at 4.2.0 color sampling.
Okay, 4.2.0, what does that mean practically?
It means it's slightly compressing the color information to fit the bandwidth, fine for most movies and TV, but it also does 4K 30 at full 4.4.4 color sampling.
4.4.4 is better.
It's uncompressed color. Every pixel gets its full color data, crucial for things like computer text, graphics, medical imaging, where color accuracy is paramount. So the fact it supports 4K 30, 4.4.4 is significant.
That's a really important distinction. So it depends on the application. And it's running at 10.2 gigabits per second bandwidth.
Correct. That's the pipe it's working with.
Okay, now the really practical bit. Distance. This thing is built to go far. How far are we talking?
Right. So for standard 1080p HD, it can push that signal up to 330 feet. That's 100 meters. Pretty impressive.
100 meters, wow. Okay, what about 4K?
So the general specs mention up to 330 feet for 4K 60 4.2.0 and 4K 30 4.4.4 using CT6, 6A, or 7.
Right.
However,
There's always a however.
there often is. The detailed specs for the specific model clarify that for 4K 60 Hz, the range is actually 35 meters, so about 115 feet.
Okay, still decent, but significantly less than 330 feet.
Exactly. It really underlines why you need to check the precise specs for your specific needs: resolution, frame rate, cable type, all play a role. 330 feet seems to apply more to the 1080p or maybe the 4K 30 signals here.
Good clarification. Checking the details matters. What about compatibility stuff like copy protection?
Yeah, crucial point. It's compliant with HDCP 2.2 and HDMI 2.0.
Which means?
Which, for you, means it'll play nice with protected 4K content. Think Blu-rays, streaming services like Netflix and 4K. It also ensures broad compatibility with modern TVs, sources, projectors.
Essential stuff. And you mentioned earlier, this is just the transmitter.
Correct. Very important note. This is the transmittal only. It needs a friend at the other end.
So you need a compatible HDBaseT receiver, like one of their matrix cards, or does the display need it built in?
Either one works. You could feed this into an HDBaseT input on a compatible projector or display, or into a dedicated HDBaseT receiver box, or into something like a WolfPack matrix switcher card. It's part of a system.
Okay, system thinking required. It also mentions POC, power over cable. How big a deal is that in the real world?
Oh, PSC is it's genuinely a huge convenience, sometimes a lifesaver in tricky installs.
Really? Why?
Because it means you only need a power outlet at one end of the link. Either the transmitter or the receiver can power the other, assuming both support POC.
Ah, so if the projector's up in the ceiling with no easy power access.
Exactly. You power the transmitter down below, and it sends power up the same CT6 cable to the receiver or the projector's HDBaseT input. Fewer cables, fewer power points needed. Big win, especially in complex setups. We used it on an auditorium job once. Saved hours.
I could see that being incredibly useful.
Yeah.
Okay, so we have the picture covered, power convenience. What about the rest of the experience? Audio.
Yeah, it's not just video. It handles high-end audio formats, too. We're talking uncompressed stuff like 7.1 DTS Master HD and Dolby True HD.
So full cinema sound quality.
Pretty much. Plus, it supports HDR high dynamic range and Dolby Vision, again within that 10.2 GBP's bandwidth, so you get the better colors, contrast.
The whole modern visual package.
Right, and even 3D, if that's still your thing, at 4K 60 Hz apparently. It covers a lot of bases.
Okay, interesting. There's another feature listed. CEC, Consumer Electronics Control. I've seen this on menus, but what does it actually do?
CEC is one of those features that sounds amazing on paper. The idea is your TV remote can control other connected HDMI devices.
Like your Blu-ray player or soundbar?
Exactly. So theory is you hit play on the player and the TV turns on, switches input, maybe the receiver fires up too. One remote to rule them all, kind of.
Okay, that sounds handy. What's the catch?
The catch is interoperability. While most big brands support some form of CEC, LG calls it Simple Link. Samsung calls it AnyNet plus Sony has Bravia Sync. They don't always play nicely together.
So my Sony TV might only reliably control my Sony Blu-ray player.
That's often the case, yeah. It's not a strictly enforced standard across brands for full functionality, so it can simplify things, but don't bank on perfect control across a mixed brand setup. Worth trying, but manage expectations.
Good practical advice. And just quickly, installation details, it mentions mounting clips, a screw-on power adapter, little things.
Little things that make a big difference in a permanent install. Mounting ears let you fix it securely. The screw-on power connector prevents it from being accidentally yanked out. LED status lights help troubleshoot. Pro touches.
Makes sense. Okay, stepping back a bit. We have HDBaseT, but there are other ways to send AV long distances, right? Like fiber or AV over IP. Where does HDBaseT really shine compared to those?
That's a great question. Each has its strengths. Fiber can go incredibly far and is immune to electrical noise, but it's generally more expensive and the cables are more fragile.
Okay. And AV over IP, sending video over the network.
AV over IP is super flexible, scalable to huge numbers of screens, uses standard network gear, but it almost always involves some video compression, and there's inherent latency, a delay, because the signal's being chopped up into packets, sent, and reassembled.
Right, that encoding-decoding delay.
Exactly. So HDBaseT's sweet spot is where you need uncompressed, zero-latency video and audio over significant distances up to that 100 meters or so, using cost-effective, easy-to-install seat cable.
So boardrooms, high-end home theaters, auditoriums, digital signage, where pristine quality and real-time response are key.
Precisely. It hits that balance of performance, distance, and cost really well for those applications without the latency penalty of IP or the cost fragility of fiber for those distances. And it's built to handle future formats too.
You mentioned zero latency, and the source material actually quantifies it. Less than 7 microseconds over 330 feet. That sounds impossibly fast.
It's incredibly low. We're talking millionths of a second. Compare that to maybe 30, 50, even 100 milliseconds or more for some AV over IP systems.
Oh, 1,000 times faster, roughly.
Or more. What that means for you, the user, is perfect lip sync, always, even on massive screens far from the source.
Like the church or auditorium example they gave.
Exactly. Or think about interactive displays or gaming. Any delay is perceptible and detrimental there. HDBaseT effectively eliminates that transmission delay. It feels instantaneous.
That immediacy is key. Okay, to wrap this up, let's touch on installation best practices. The source was pretty specific about handling the CIT cables. What are the crucial do's and don'ts?
Yeah, this is super important for getting reliable performance. Getting
Right.
the cabling wrong is probably the #1 cause of issues.
So what's rule number 1?
Rule 1, use the TIA-EIA 568B wiring standard when you terminate the cables. That's the color code for the little wires inside. Get it right consistently on both ends.
Yeah, 568B standard. Got it.
What else?
It specifically warns against using those easy RJ45 connectors, the pass-through kind,
Oh, interesting. Why?
and also advises against using patch panels in the run. While convenient for networking, both can potentially introduce tiny impedance bumps or signal reflections that HDBaseT, being so high bandwidth and uncompressed, is sensitive to. It can cause glitches or dropouts. Direct runs with quality standard terminations are best.
So minimize functions, use standard terminations. What about cable type?
Use shielded CP6 or Cat6A, ideally with shielded metal connectors. The shield helps protect against electromagnetic interference, EMI.
Like noise from power cables, fluorescent lights, mobile phones. Exactly. That EMI can cause random video flashes or instability. So shielded cable, properly grounded, and keeping the cable runs away from major sources of EMI is really recommended for the cleanest signal.
Makes sense. Treat the cable with respect.
Absolutely. It's carrying a very demanding signal.
Okay, so we've really unpacked the WolfPack HDBaseT transmitter. We've seen how HDBase tackles long-distance AV using standard Ethernet cable, delivering uncompressed, zero-latency signals.
Yeah, supporting high resolutions like 4K, including that important 4.4.4 color for specific uses, plus advanced audio, HDR, Dolby Vision.
And practical features like power over cable making installs easier, plus things like CEC, even if it has its quirks.
And you've hopefully learned how crucial the details are, like understanding color sampling differences, checking exact distance specs for your resolution, and following those installation best practices carefully.
It's definitely more than just plugging in a cable.
For sure, it's about enabling those really high-quality, reliable digital experiences wherever you need them.
So here's a final thought for you to consider. As you think about your own AV challenges, how does that core HDBaseT promise no compression, no latency, potentially change how you approach system design?
Yeah, think beyond just making the distance.
Right. How could that level of signal integrity and responsiveness open up new possibilities? For truly integrated, seamless, high-performance environments, whether that's at work, in education, or even in your ultimate home setup?